Imagine a gravitational anomaly so powerful it's pulling our galaxy towards it at a speed of 600 kilometers per second. This titanic force is not a figment of science fiction, but a fascinating reality. It's known as the Great Attractor, a name that evokes a sense of mystery and intrigue, much like the phenomenon itself. First discovered in the 1970s, the Great Attractor has since been a subject of intense study and speculation. It was during this era of space exploration that astronomers detected a peculiar motion of galaxies, including our own Milky Way, moving in a specific direction. This mass migration was not random but seemed to be influenced by some unseen gravitational force. Thus, the concept of the Great Attractor was born. The Great Attractor resides in a region of intergalactic space approximately 250 million light-years away from us. It lies near the center of the Laniakea supercluster, a colossal cosmic structure that includes our Milky Way among its 100,000 other galaxies. This gravitational anomaly is so powerful it's not just pulling us, but millions of galaxies towards it. And that's where the plot thickens. The Great Attractor isn't just an astronomical curiosity, it's a conundrum. Despite its immense gravitational influence, we don't know what's causing it. Is it a supermassive black hole, a dense cluster of galaxies, or something entirely unknown to modern science? The answers are elusive, and the Great Attractor continues to defy our understanding. One of the reasons the Great Attractor is so enigmatic is its location. It's positioned in a region known as the Zone of Avoidance, an area heavily obscured by the dust and gas of our own Milky Way. This cosmic curtain effectively hides the Great Attractor from our view, making it incredibly challenging to study directly. Despite our best efforts, the Great Attractor remains largely a mystery, hidden from our view by the Zone of Avoidance. So, what could be causing this massive, mysterious pull? Scientists have some theories. One of the most fascinating aspects of the Great Attractor is the sheer number of theories that have been proposed to explain its existence. A popular theory is that the Great Attractor could be a supercluster of galaxies. Superclusters are the largest known structures in the universe, consisting of groups of smaller galaxy clusters. Given the immense gravitational pull of the Great Attractor, it's plausible that a supercluster could be at its core. However, despite the appeal of this theory, it's not the only one. Some scientists propose that the Great Attractor could be an area rich in dark matter. Dark matter is a hypothetical form of matter that doesn't interact with electromagnetic forces, meaning it doesn't emit, absorb, or reflect light. This makes it invisible and undetectable by traditional means. Its presence is only inferred from its gravitational effects on visible matter. If the Great Attractor is indeed a concentration of dark matter, it could explain the gravitational anomaly we're witnessing. Yet another theory is that the Great Attractor could be a massive black hole. Black holes, with their incredibly strong gravitational pull, could theoretically attract galaxies towards them. However, if a black hole were responsible, it would have to be incredibly massive, far larger than any black hole we currently know of. What's intriguing about these theories is that each one presents its own set of questions and mysteries. If the Great Attractor is a supercluster, why haven't we observed it directly? If it's a concentration of dark matter, how did it amass such a large quantity? And if it's a massive black hole, how did it form, and why haven't we detected its presence? Yet, despite the many theories, none have been confirmed. Each one is based on our current understanding of the universe and its laws, and each comes with its own set of assumptions and implications. While these theories are compelling, we still don't have conclusive evidence to support any one of them. One of the biggest challenges in studying the Great Attractor is that it's located in the Zone of Avoidance. This zone isn't a sci-fi invention, but a real part of space, a region of the sky that is avoided by astronomers due to the obscuring effects of our own galaxy, the Milky Way. You see, the Zone of Avoidance is that section of the night sky filled with the densest parts of the Milky Way. It's a bustling neighborhood of dust, stars, and gas, all of which create a sort of cosmic fog. And just as fog on a chilly morning obscures your view of the road ahead, this interstellar fog makes it incredibly difficult for telescopes to see beyond our galaxy. But what does that mean for our study of the Great Attractor? Well, it's like trying to study a mountain peak while standing in a valley filled with fog. You know it's there, its gravitational pull is affecting you, but you just can't see it. This is the cosmic challenge that scientists face. They're trying to observe and understand an enormous gravitational anomaly located in the very area of space that our galaxy's dust and stars make most difficult to examine. It's like trying to read a book with the lights off. This makes the Great Attractor one of the most elusive mysteries of the universe. Given these challenges, you might be wondering, will we ever see the Great Attractor? Well, don't let your spirits fall yet. The answer lies in the relentless progress of technology, which might just offer us a peek beyond the elusive zone of avoidance. Our current understanding of the universe has been shaped by our ability to perceive light. But the dust and gas in the zone of avoidance blocks visible light, making the Great Attractor an unseen shadow. So how can we see what light cannot reveal? The answer could lie in the use of radio waves and X-rays. Unlike visible light, these waves can penetrate the cosmic murk, giving us the potential to map the unseen. Already, radio wave observations have provided glimpses into the zone of avoidance, hinting at the massive structures that lie within. In addition, future space telescopes could be equipped with advanced tools to detect these waves more accurately. Imagine a device so powerful it could pierce through the cosmic veil to reveal the secrets of the Great Attractor. Unfathomable, isn't it? Of course, these are merely possibilities. The formidable challenge of observing the Great Attractor remains. But with every technological advancement, we edge closer to turning these possibilities into reality. While we may not be able to see the Great Attractor with our eyes, science is getting us closer to solving this cosmic mystery.